In section 2.2, we're going to study molecular elements and compounds. A molecular compound is a pure substance composed of molecules made up of two or more non-metallic elements. A covalent bond is the bond that results from the sharing of a pair of electrons by two atoms. Not all of the atoms on an element's outer shell are available for bonding. Only bonding electrons are those that can participate in a covalent bond. A bonding electron is an electron in the valence shell of an atom that is available to form a covalent bond with another atom. Let's take a look at hydrogen in this table. Hydrogen has a single atom. That atom is a bonding electron. It is capable of forming a covalent bond. We say that hydrogen has a bonding capacity of 1. The bonding capacity is the number of covalent bonds that an atom can form. So hydrogen can form 1 covalent bond and has a bonding capacity of 1. Take a look at carbon. Carbon has 4 single electrons. It has a bonding capacity of 4 and is capable of producing 4 covalent bonds. Let's take a look at nitrogen. Nitrogen has 3 bonding electrons and 2 non-bonding electrons. These 2 electrons are called a lone pair. A lone pair is a pair of electrons that is not involved in covalent bonding. Oxygen has 2 lone pairs and 2 bonding electrons. Fluorine has 3 lone pairs and only 1 bonding electron. So you can see from this table that of the valence electrons that are present, the lone pairs are not available to form bonds. Only the bonding electrons are available. A single covalent bond forms when 2 different atoms share a pair of valence electrons. If we take a look at the example between hydrogen and chlorine, each with 1 bonding pair electron, they can form 1 covalent bond. In the example of 2 oxygen atoms, each oxygen atom has 2 bonding electrons, and these 2 bonding electrons are available to form 2 covalent bonds. When 2 nitrogen atoms combine to form molecular nitrogen, the nitrogen atoms share 3 pairs of valence electrons in order to satisfy the octet rule. When atoms share 3 pairs of electrons, they form a triple covalent bond. So each has 3 bonding electrons, and these bonding electrons can form 3 covalent bonds, and we end up with a triple bond. So you can have a single covalent bond, a double covalent bond, and a triple covalent bond. Let's learn how to draw Lewis structures for molecular compounds. We're going to, in our first example, draw a Lewis structure for the molecule methanol, CH2O. Step 1. Arrange the symbols of the elements in the compound so that the element with the largest bonding capacity is in the center, surrounded by the elements with smaller bonding capacities. Carbon has a bonding capacity of 4. Hydrogen has a bonding capacity of 1. And oxygen has a bonding capacity of 2. The element with the largest bonding capacity is carbon, and we're going to place it in the center. Around the carbon, we're going to place the elements with the smaller bonding capacity. Step 2. Count all the valence electrons for all the atoms in the molecule. This total represents the total number of electrons that can be used in the Lewis structure. Carbon has 4 valence electrons. Oxygen has 6 valence electrons. There are 2 hydrogen atoms, and each has 1 valence electron. So a total of 2 valence electrons, and 4 plus 6 plus 2 is 12 electrons available for the Lewis structure. In step 3, we're going to place 2 electrons, a single covalent bond, between the central atom and each of the surrounding atoms. So we're going to place 2 between the central atom and each of the surrounding atoms. In step 4, we're going to complete the octet of each of the surrounding atoms, except for hydrogen, to satisfy the octet rule for each surrounding atom. So let's take a look at oxygen. In order for oxygen to complete the octet rule, it currently has 2 electrons around it. I need to place 6 more. 1, 2, 3, 4, 5, 6. Actually, the step goes here. I've combined the 2 steps. But let's separate them so we can look at what we're doing at each step. Step 5, if the central atom does not have an octet, and let's take a look at that for a moment. Carbon. Does it have an octet around it? It has 1, 2, 3, 4, 5, 6. If it doesn't have an octet, move electrons from the outer atoms to form double or triple bonds. So I'll draw it again as it is. And I'm going to take 2 atoms from oxygen, because oxygen has an octet, and I'm going to use it to make a double bond. I'm going to replace the shared pairs of electrons with dashes. And I use a double dash to represent a double bond. This is the most symmetrical arrangement of the atoms around the central atom. And we've spaced them so that they are equally spaced around the atom. Now we can redraw this without the lone pairs And this is our Lewis diagram for methanol. Now let's take a look at a Lewis diagram for a polyatomic ion. Remember, a polyatomic ion is an ion that is made up of two or more elements and has an overall charge. In step 1, we're going to arrange the symbols of the elements in the compound so that the element with the largest bonding capacity I'd like to correct that for a moment. So that there is, let me just correct this. We want to arrange the symbols of the elements so that there is a single atom in the center. We have 1 chlorine and 3 oxygen. So we're going to place the chlorine as the single atom in the center, surrounded by 3 oxygens that are equally spaced. In step 2, we're going to count all the valence electrons for all the atoms in the molecule, and this total will represent the number of electrons that can be used in the Lewis structure. Chlorine has 7 valence electrons. There are 3 oxygen, each with 6 valence electrons. That's 18 electrons. Plus we have a -1 charge. So that's 1 electron. If we add those together, 7 electrons plus 6 electrons, or 18 rather, plus 1 electron, is 26 electrons available for this Lewis structure. In step 3, we're going to place 2 electrons, a single covalent bond between the central atom and each of the surrounding atoms. We're going to complete the octet of the surrounding atoms except for hydrogen to satisfy the octet rule. One, 2, 3, 4, 5, 6 gives oxygen 8. Oxygen 8. Oxygen has 8. And let's determine how many valence electrons are still available. Let's count them all. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we had 26 electrons to start with, minus 24 that we've drawn. That gives us 2 electrons. We're going to place the remaining electrons on the central atom myself. I'm going to do that here. So Cl. Place 2 additional electrons on the central atom. If the central atom doesn't have an octet, move electrons from the outer atoms to form a double or triple bond. In this case, the oxygens have an octet and the central atom has an octet, so no lone pairs have to be moved. There are no double or triple bonds. And we're going to replace the shared pairs of electrons with dashes to represent covalent bonds. Place square brackets around it and indicate the overall charge. To convert the Lewis structure into a structural formula, remove any of the dots representing lone pairs. And there you go, we have our Lewis structure converted into a structural formula for the chlorate ion. Now, molecular compounds are different in their properties from ionic compounds that we studied in section 2.1. Molecular compounds are solids, liquids, or gases. The solids can be soft, waxy, flexible, or crystalline. They have low melting points and boiling points, poor conductors of electricity when dissolved in water, and poor conductors of electricity in the liquid state. And examples include water, carbon dioxide, methane, and sucrose. Please try any practice problems assigned and any LMS quizzes that you are required to do.